Okay, this is section R.6, which is about synthetic division. Now, I made a video about R.4, which is long division, and synthetic division is pretty much the same process. The only difference is you can only do synthetic division when you're dividing by a linear function. So when there's a linear divisor, then you can do it. So let me show you an example. Suppose we have something like 2x cubed minus x squared plus 3, and what we want to do is we want to divide this by x minus 3. Okay. Of course, another way to write this would be to say we have 2x cubed minus x squared plus 3 all divided by x minus 3. Okay, so let's do this with long division first, and then we can make a comparison. So we have 2x cubed minus x squared plus 3, and we're going to divide that by x minus 3. Okay, so what do we need to multiply by x to give us 2x cubed? We need to multiply 2x squared by that. So 2x squared, and then 2x squared times x is going to be 2x cubed, and 2x squared times negative 3 is going to be minus 6x squared. As a matter of fact, up here I should have put plus 0x and then plus 3. Okay, so now I'm going to change all the signs, and I'm going to add down, and that's going to give me 5x squared. Then I'm going to bring this down, so then I have plus 0x plus 3, and I'm going to go through the process again. What do I need to multiply x by to give me 5x squared? That would be 5x. So 5x times x is 5x squared. 5x times negative 3 is negative 15x. And now I'm going to change all my signs, and I'm going to add down, and I'm going to get 15x, and then I'm going to bring this 3 down, and I have plus 3. What do I need to multiply x by to give me 15x? That's 15. So 15 times x is 15x, and then 15 times negative 3 is going to be negative 45. So I'm going to change all my signs, and I'm going to add down, and I'm going to get 48. So I get that the quotient is 2x squared plus 5x plus 15, and the remainder is 48. So that's what we get. Now, if we go through this process, first of all, there's a lot of kind of recopying and symbols that we're using here. If you're really careful about lining up all of your terms, so like when I say that, I mean like that we're lining up the x cubes here, x squareds here, we're putting the x's are all going here, and the numbers are going at the end. If we're really careful about doing that, then we don't really need to write all the x's and stuff like that, do we? I mean, we don't really need to write all that stuff. So we can do the same thing by doing this long division process. Okay, so, or I'm sorry, this synthetic division process. So let's look and see what that would look like. We're going to just copy the coefficients. So we have 2x cubed, and then we have minus 1x squared, we have 0 x's, and then we have 3. And we're going to divide this by 3. Alright, so as a matter of fact, I was always kind of used to doing this down. Alright, so what we're going to do is the very first thing we're going to do is we're going to bring down the 2, then we're going to multiply. 3 times 2 is 6, we're going to add down, and that's 5. 3 times 5 is 15, add down, that's 15. 3 times 5, that's 45, add down, that's 48. So if you notice, like these remainders, the very first thing that we had was the 2, and then this was a 2. Then we had a 5. Look, there's the 5. We had a 15. Then there's a 15. And then we had a 48. And then there's our 48. So in other words, it's essentially going through the same process. It's just a different way, and it's faster. But just keep in mind that you can only do this when you're dividing by a linear term. The divisor is a linear, so we can do this. The whole reason we still have to talk about long division is if the divisor was like x squared minus 3, you could not do synthetic division. So it's important to keep that in mind. Synthetic division can only be done when you're dividing by a linear factor. Okay, so let's kind of go through some examples. Also, something that's really important, let me give you guys this connection too, because this is really, really important as well. What we're doing here is 48 is the remainder, and then the quotient, these are the coefficients of the polynomial for the quotient. So this will always be a constant term, the next will be linear, the next one will be quadratic, and it's just going to continue down the path however far you have. So in other words, we found that 2x cubed minus x squared plus 3, and that's, I'm just pulling these coefficients, so 2x cubed minus x squared plus 0x plus 3 divided by x minus 3 is equal to, and now I'm going to pull these coefficients and I'm going to say that's 2x squared plus 5x plus 15, and then plus 48 over x minus 3. Okay, and so it's like, well, how did you know I needed to start with an x squared? Well, I just counted. This is constant, that's linear, that's quadratic, and so that's why I knew I needed to start off with an x squared term. Okay, so that's the idea. This is synthetic division. Okay, so now let's go through some more examples. So let's look at an example here. This says use synthetic division to show that x plus 3 is a factor of 2x to power 5 plus 5x to power 4 minus 2x cubed plus 2x squared minus 2x plus 3. Alright, so let's do that. Alright, the first thing that we're going to do is we're going to write all these coefficients. So we have 2x to power 5, 5x to power 4, negative 2, then 2, then negative 2, and then 3. Alright, and so now we're dividing this by x plus 3. So that means that if it's x plus 3, it's always got to be written in the form of x minus, like, because those are the factors, right? That's the form that we, remember if r is a 0, then x minus r is a factor. So we need to write it into that form. So this is going to be x minus negative 3. So that means negative 3 is what we're going to be using for our quotient, or for our divisor, I should say. So now we're going to bring down the 2. We're going to multiply. Negative 3 times 2 is negative 6. So you multiply here, so kind of crossways. So it's like negative 3 times 2, and then that's negative 6, and that's where you put the answer here. So it's kind of diagonally. Then we add down. So that's sum, 5 and negative 6 is negative 1. Then we multiply again. Negative 3 times negative 1 is positive 3. Add down, that's 1. Negative 3 times 1 is negative 3. Add down, that's negative 1. Negative 3 times negative 1 is positive 3, add down, that's 1. Negative 3 times 1 is negative 3, add down, that's 0. So here's what we found. We found that 2x to power 5 plus 5x to power 4 minus 2x cubed plus 2x squared minus 2x plus 3, when you divide that by x minus negative 3, or you could just write it as x plus 3, what you get is you get a quotient of, and let's count, constant, linear, quadratic, cubed, and then x to power 4. Okay, and also it's always going to make sense that your quotient drops down 1 power from your original dividend. So the original number that was, originally this was a 5th degree polynomial. When you divide it by a linear, it's going to become a quartic. And the reason is because if you think about it, x to the power 5 divided by x, that's x to the power 4. So that's why it's going to drop down 1 power. And I mean, I know we're not dividing exactly by that. It's just 2x to the power 5 plus 5x to the power 4, all this stuff divided by x plus 3. That's certainly true, but the degree will be the same. So it turns out that this is 2x to the power 4 minus x cubed plus x squared minus x plus 1. That's the quotient, and then plus the remainder is 0 over x plus 3. So 0 over x plus 3 means that that's 0, so you could really just not even write that piece. Well, so if you recall, now if we multiply both sides by x plus 3, and we talked about this, the quotient remainder kind of form when we were doing long division. This is 2x to the power 5 plus 5x to the power 4 minus 2x cubed plus 2x squared minus 2x plus 3. We found that that's equal to 2x to the power 4 minus x cubed plus x squared minus x plus 1 times x plus 3. So that means that we have shown that x plus 3 is a factor of 2x to the power 5 plus 5x to the power 4 minus 2x cubed plus 2x plus 2x squared minus 2x plus 3. We haven't completely factored it, but we've started, and we've started to factor it. So actually, if we continue this process and we keep going here, what this will actually enable us to do is just take something like a fifth degree polynomial and potentially be able to factor it all the way down. In truth, you should be able to always factor something like this into a product of linears and irreducible quadratics, which we'll talk about that later when we get to the fundamental theorem of algebra. But that's the point. We've shown that that is a factor. Okay, let's do another example here. Let's see. Okay, so let's go and go through some more examples. This is number 6 on page 62. It's of course section R.6. The directions are: use synthetic division to find the quotient and the remainder when, and it says x cubed plus 2x squared minus 3x plus 1 is divided by x plus 1. So again, is this divisor linear? Yes, it's a linear factor. So, or I should say, it's a linear. It's a linear function. So certainly that means we can use synthetic division. So we're going to write the coefficients 1, and then we have 2, and then we have -3, and then we have 1. And look, that goes cubic, quadratic, linear, and then constant. So we're not missing anything. We don't need to put in zeros. And then this is going to be a -1. So we're going to bring down the 1, multiply, that's -1, and then add, that's 1, multiply, that's -1, add down, that's -4, multiply, that's 4, add down, so that's 5. And so that means that what we found is the quotient is x squared plus x minus 4, and the remainder is 5. So there we go. All right, let's do another one. So remember where I got these. Look at these coefficients. We have 1, 1, and -4. So that's 1, 1, and -4. And the remainder is 5. So remember that that's where that comes from. All right, let's do another one. This is number 8. We're going to figure out what is -4x cubed plus 2x squared minus x plus 1 divided by x plus 2. So this is the same thing as, so we're going to have a -2, because remember this is x plus 2, so that's x minus -2. It's got to be written in the form x minus c or x minus r, and then you put that value here. And then we're going to write the coefficients -4 and then 2, and then -1 and 1. And if you look, there's no gaps, so there's not any terms missing. It's cubic, quadratic, linear, and then constant. So we're in good shape. We're going to bring down the -4. We're going to multiply. So -2 times -4 is +8. Add down, that's 10. Multiply -2 by 10, that's -20. Add down, that's -21. Multiply, that's going to be +42. And then add down, that's going to be 43. So we found that -4x cubed plus 2x squared minus x plus 1 divided by x plus 2 is equal to, go away, is equal to -4x cubed, I'm sorry, -4 x squared plus 10x minus 21 plus 43 over x plus 2. And remember, if you rewrite that in the right form, or I should say in the alternative form, by multiplying both sides by x plus 2, you found that -4x cubed plus 2x squared minus x plus 1 is equal to -4x squared plus 10x minus 21, all multiplied by x plus 2, and then plus 43. So what's important to keep in mind is if the remainder is 0, then that means that the divisor was actually a factor of the original polynomial. So in other words, if the remainder here was 0, if this had been 0, then that means that this, which was the divisor, is actually a factor of the original dividend, or the original polynomial that we were looking at. The point is that the quotient is here, that's the quotient, and the remainder is here. Okay. I mean, all you have to do is identify the quotient and the remainder. I just wanted to show you guys that you could express it that way, and it's the same thing. All right, let's do one that's got some gaps. So how about this is number 10. Whoops, that's number 10. Same page and everything. So we're going to figure out what is x to the power 4 plus x squared plus 2 when you divide it by x minus 2. Okay, all right, so let's do this. We have 1x to the power 4 plus 0x cubed, because there's no x cubes, so plus 0x cubed, plus 1x squared plus 0x, because there's no x term here, and then plus 2. And we're going to divide that by -2. -2 is the like that r value. Remember, if r was a 0, and you have to say like x minus r is a factor, so you have to put it into that form. So I'm sorry, it's just 2 actually, because it's x minus 2, so 2 is what goes there. It's always got to be written in the form x minus r, and then whatever r is what goes here to use. All right, so that being said, we're going to bring down the 1, multiply, which is 2, and then add down, which is 2. Multiply, that's 4. Add down, which is 5. Multiply, that's 10. Add down, which is 10. Multiply, that's 20. Add down, which is 22. Okay, so let me just check this really quick. Brought down the 1. 2 times 1 is 2. Add down, which is 2. Multiply, which is 4. Add down, which is 5. Multiply, which is 10. Add down, which is 10. Multiply, which is 20. Add down, which is 22. There you go. So the quotient is, look, this is always going to be the remainder, and then this is going to be constant, linear, quadratic, cubic. So it looks like the quotient is going to be x cubed plus 2x squared plus 5x plus 10, and the remainder is 22. All right, let's do another one. How about this one? This is number 12. We have x to the power 5 plus 5x cubed minus 10, and we're going to divide this by x by x plus 1. Okay, so let's go through the process. This is 1x to the power 5 plus 0x to the power 4, because there's no x to the power 4, is plus 5x cubed plus 0x squared plus 0x, and then minus 10. And then this is, we're dividing this by x plus 1, which is the same thing as x minus negative 1. And remember, negative 1 is what we're going to put here. So this is negative 1. So I started off by bringing down the 1. Negative 1 times 1 is negative 1. Add down, which is negative 1. Multiply, negative 1 times negative 1 is positive 1. Add down, which is 6. Multiply, that's negative 6. Add down, which is negative 6. Multiply, which is positive 6. Add down, which is positive 6. Multiply, which is negative 6 again. Add down, that's negative 16. So the quotient is going to be, look, this is the remainder, so that's going to be constant, linear, x to the power 2, x to the power 3, x to the power 4. So we're going to have x to the power 4, 1x to the power 4 minus x cubed plus 6x squared minus 6x plus 6. The remainder is negative 16. It's entirely possible to have some of these end up be 0, but I mean, just none of them have worked out that way. Let's do one more. Well, let's do just a couple more. This is number 16. This is x to the power 5 plus 1 divided by x plus 1. So this is going to be 1x to the power 5 plus 0x to the power 4 plus 0x cubed plus 0x squared plus 0x plus 1. And we're going to divide it by x plus 1, so that means we put a negative 1 here. We're going to bring down the 1, multiply, that's negative 1, add down, that's negative 1. Multiply, that's positive 1, add down, which is positive 1. Multiply, that's negative 1, add down, which is negative 1. Multiply, which is positive 1, add down, which is positive 1. Multiply, which is negative 1, add down, which is 0. So that means that we've found that x, well, I'll tell you just the quotient and the remainder, because that's what our directions were. Quotient is going to be, this is, remember that's the remainder, so that's constant, and then x to the power 1, the coefficient for x to the power 1, the coefficient for x to the power 2, the coefficient for x to the power 3, the coefficient for x to the power 4. So this is going to be x to the power 4 minus x cubed plus x squared minus x plus 1, and the remainder is 0. So keep in mind, guys, that if you find that the remainder is 0, then that means that x plus 1, which is the original divisor, is a factor of the dividend. I mean, like, let me put it to you, let me kind of give you a comparison. If you had something like 6 divided by 4, you know, you could write this as 1 with a remainder of 2, right? You could say 6 will go into 4 once with a remainder of 2, right? So, and we all know that 4 is not a factor of 6. If you write 6 in its prime factorization, 6 is going to be 2 times 3. Well, similarly, if we took 6 and we divided it by 2, which is one of the factors, then you're going to get 3 with a remainder of 0. So the point is if you take a dividend and you divide, if you look at the divisor, if the divisor is actually a factor of the polynomial or of the original dividend, then that means that the remainder will always be 0. You know, similarly, if you divided 6 by 3, you would get 2 with a remainder of 0. But if you divide it by, like, you know, 5, 6 divided by 5, then you would get 1 with a remainder of 1. Your point is you're going to get a remainder that's not 0 when the divisor is not a factor of the dividend. So just keep that in mind. Okay, it's the same kind of thing that we're finding here. So that being said, let's do, so we know when the remainder is 0, then we know that the divisor is a factor. Okay, so let's look at number 18. Now the directions have changed. The directions are determine if x minus c is a factor of the polynomial. Okay, so in other words, the given polynomial that we're going to be given is negative 4x cubed plus 5x squared plus 8. And the x minus c is going to be, we're given x plus 3. So that means that that's the same thing as x minus negative 3. Okay, so that means that this is really like x minus negative 3, so negative 3 is the c value. Okay, so we want to determine if x minus negative 3, in other words x plus 3, is a factor of this polynomial. So let's determine that. So we have negative 4, we have 5, we have 0x squared, because there's no linear term, there's no x to power 1 term, so we have 0 x to power times x to power 1, and then 8. Okay, and then the value that I'm going to check is negative 3, so that's like the c value, which means I'm doing a divisor of x plus 3. I'm going to bring down the negative 4. I'm going to multiply, that's 12, add down, which is 17, multiply, that's going to be negative 51, I think. Is that right? 50, yeah, negative 51. Add down, which is negative 51, multiply, that's going to be positive 153. And when I add down, that's going to be 161. So this is absolutely not 0. It's a pretty big value if you're considering, like looking for 0. So in other words, the answer is no. X plus 3 is not a factor of negative 4x cubed plus 5x squared plus 8. Let's do another one. This is number 20. Same directions. So we have, now we're checking 4x to the power 4 minus 15x squared minus 4. Okay. And we're checking the divisor is x minus 2. So that means we have 4, we have 0 x cubes, we have negative 15x squareds, we have 0 x's, and then we have a negative 4. We're going to divide that by x minus negative 2. So negative 2 is what we're going to put there. We're going to bring down the 4, multiply, negative 8, add down, negative 8, multiply, 16, add down, 1, multiply, negative 2, add down, negative 2, multiply, that's 4, add down, which is 0. We got a remainder of 0. So since we get a remainder of 0, then that means the answer is yes. Whoops. The answer is yes. X minus 2 is a factor of 4x cubed plus 0x squared minus 15x. No, this is 4x to the power 4 plus 0x cubed minus 15x squared plus 0x minus 4. Yeah, so that was the original. Okay, so you can easily determine if it's a factor. Okay, I hope this video is helpful to kind of refresh synthetic division. So there you go.